this video is going to be the beginning of this particular build. Instead of kind of showing an end reveal like I normally do, I'm going to be doing something a little different for this one. I'll break it in parts a little bit so we can kind of see it come together. For those who don't realize, this is a Lian Li Evo XL. That's one of the reasons I also chose to do this video with this case, because it's a very popular case. So we'll go into part selection and some of the constraints I have for this build, and then I'll kind of give you a breakout of my thinking, and then we'll go into how I'm going to make it happen. Okay, so first off, this is an AM5 platform. This is the X670E Extreme. I did pick this board for this build because I'm going to be upgrading to the 9000 series in about a week or two. Okay, so I don't know if I will have the X870E boards in the Extreme format. I don't know when that's coming. I don't even know if it's coming. I assume it is. So I'm going to use the X670E one for, I guess, in the meantime. And I'm pretty sure, you know, it'll be perfectly serviceable anyway. So with that said, I have it in the inverted position, or some people like to say upside down. Outside of that, I have a 4090 Strix that's on Heatkiller block, and I've already pre-installed a Heatkiller 420 on top and a Heatkiller 420 on the bottom. I'm using the Lian Li TL LCD fans for the bottom and the regular TL for the top. This build, if you haven't noticed, has Heatkiller radiators, Heatkiller CPU block, Heatkiller GPU block, and obviously it's going to have a Heatkiller CPU pump res combo. Reason being is this is a build for Heatkiller, Watercool Heatkiller, so that's why. They were nice enough to send some toys for me to play with, so I'm going to do a build with all their blocks and rads. So right away, you'll kind of see that I already planned it out. I plan to have my air come in from the bottom. These are reverse LCDs, and exhaust from the top. Now the side is empty because I'm going to create a reservoir mount using for the Heatkiller reservoir on the side, mounted to a distro, and then that will handle the pump res to the radiators, and then and the GPU block, and then I'm going to do something elsewhere for these runs to meet up with this and this port. I know it sounds totally confusing and didn't make sense right now, but I will now take you guys into Fusion, and you'll get a better idea what I'm trying to do. I'll isolate this bracket, and you can see that because I have the CAD, I can easily design something on here. I know where all the holes are, and that's essentially what I have over here. So this is just, you know, you can just export this bracket into another file and then open it. So this is the bracket itself. So you'll see that, see the bracket. So I've taken the measurements from the bracket and projected it up. You can watch some Fusion guys online. I'm not a professional at this, but I know it well enough to kind of do what I need to do. So right away, I made a sketch to where this is kind of the outline of the Heatkiller reservoir. This is the entire width of it, 70 millimeters. This inside are the mounting holes for the reservoir, which is why there's going to be a hole there. So if I hide the original body and I come in here, you'll see that I have screw holes passing through. Obviously, there are no runs on this yet, right? This is kind of just a mock-up. What I usually do at this point is I make a cutout. So if I hide all this, and I'll show you guys, see this basic sketch, and I put on my test plate. Now that we're looking at the plate, my test plate, I cut these holes myself. I measured them where their locations would be, and my plan is to mount the Heatkiller reservoir here, and then these ports are going to match the in and out that's on the res itself. I've already cut this out so I can show you guys what I mean. I've chosen these temporary mounting locations for screws to mount to the original plate, right, to the original body plate. I could use the 360s here and the 420s, but unfortunately I'm going to have some tube runs right here, water channels on here, this side and this side, so I can't put a screw there. I put them on the extreme ends. You're not going to see them from the front because if I put back, sorry guys. So this is the bottom of the distro plate, right? And this is the lid of the distro plate. So the screws will come through from here. You'll see that. It's example here. Sorry guys. Really struggling without my Space Mouse. It's like from here, for example, I'll put a mounting screw here, and I'll make a thread on the rear of the acrylic plate, and that will be a good place to mount the screw. Like same goes for here, right? Same goes for here. Well, that's too low. Maybe like here. I have a screw here already. So stuff like that. So that will make it mount, and you won't see any of the screws because this will come in. So what I'll do now is I'll show you guys the plate. I've already cut it out. So you can see here I've cut out that plate I was talking about. This is 3mm acrylic. Obviously I do not suggest you mount a reservoir on 3mm acrylic. Even though this is backed into that metal piece, I would still not suggest it because it will crack over time, especially removing it around. It's just not good enough. Like at least 3mm. If you want to use 3mm, use 3mm aluminum. But anyway, so the point being is my Heatkiller radiator is up here. Sorry, radiator, reservoir, pump res is here now. And what I was trying to tell you guys from the beginning was that this is obviously not the right length, but I plan to say, for example, run one here, run one here, and if the GPU, you can see I'm going to do something like that, and then something like that. Obviously, I'm going to have all 4 ports be at the same height, so it's a symmetrical look, right? So, and then for this portion, the CPU, I'm going to have both of them come out, hit something around here that will then connect these 2 ports, right? So that's pretty much the plan. Right now, my focus is only to figure out a couple locations, these primarily being the GPU in and out, and the radiator to this part. So I'm not including the CPU block at the moment. I'm going to go into why in a second here, but let's show you guys how I do this. Sometimes I would take I like to use metal tubing for this because the 90 is always perfect, right? So if I'm using a tube to, let's say I use a combination of fittings and tubes to mark this point, that 90 is always going to be perfect. So when I bend the perfect 90, it's going to fit. Or sometimes what I'll do is I even just build the whole fitting bridge. Obviously not everybody has any fittings laying around, but I happen to have that. Additionally, the plan here, to clarify from before, is that this out, right? This out right here on the reservoir is going to go into this radiator, right? So there will be a run here, okay? Obviously, this is going to be adjustable, right? I mean, this can be lower down, can be higher up. So when I'm measuring this, I'm only going to have to figure out X for the radiators. You know, the Y can be varying. For the GPU, I can figure out the Y, and the X can be varying, right? Because I can move it a little bit over, move it a little bit. Ideally, I'm going to make sure that these tubes are equidistant from the reservoir, so that way it's symmetrical. But yeah, that aside, we're going to go out into this reservoir here. This reservoir is going to connect with a different block, distro thing, to this GPU mount. To the CPU. So there will be another thing floating over here, which will be the connection to this. This will come back out, go into the connector here that will then feed into the radiator on top. This radiator will come out, go into the GPU in, and then come out the GPU out, which will then return into the reservoir in. I know it sounds a little bit complicated, but rest assured, it's a very simple loop. So yeah, so that's what I'm going to do now. I'm going to figure out where these holes are, and I'm going to go back to Fusion and start drawing it up.
So when I had the pump res mounted on my test plate, I noticed there's something that I missed. The pump looks like an eyesore without something covering it. And also the wire was just dangling. So I've added a wire to, a hole on the pump distro design to allow the wire to pass through. Now, I've also decided to make a pump cover. This pump cover is pretty easy to make. All you really have to do, like I've done here, is, let me just show one of the original dimensions. I take the diameter of the pump, I measure that, I give it a 0.25 additional millimeter gap, and then I give a basic shape. I measured, this is about 70 millimeters, so when it attaches on, it looks kind of natural. I extrude it out into a block, and then I give it some shaping so that it looks more like the water cool reservoir, right? In the back, I've given it a small opening where I can pass the wire through for the PWM and the Molex. Obviously, the Molex will require depinning before it can pass through, but that's easy enough. And then in the front, I've added a Watercool logo. And that kind of just ties it in with on brand. And I think something small like this is a nice touch to have. While I could machine this, but you'll notice it's 37 millimeters. This is another 3. So it's 40 millimeter thick acrylic. It's extremely expensive and not worth it if you can 3D print. For anything you can 3D print, you're better off 3D printing than machining, unless you have to machine it for whatever reason it may be. Because, subtractive manufacturing, which is machining, is a lot more expensive than, additive manufacturing, which is 3D printing. For those of you that are into 3D printers or getting into 3D printers, Fusion is a software that can generate G-code for your 3D printer, or you can just, it's so easy. You can just come here. I go to, well, I don't know if the menu is going to show up. You just export this directly to like your slicer. So yeah. So if you guys, just used to printing other people's stuff, you can also learn Fusion and make your own prints.
So the distro that holds the reservoir is done. O-ring was a total pain on this one due to the unevenness of the acrylic. But now you can see that I've mounted it. I've put the 2 tubes that run from the reservoir itself. And for those of you that are wondering, I'll move a little closer here. You can see that I am really close here. That was actually not by design. I didn't anticipate the fan being so wide, and I didn't even think about this portion. So I got really lucky. It's like not even a millimeter gap. I'm using the original bracket, so when I take it out, I slide it in and I push up, right? So I'm using the stock fan bracket to mount that whole entire piece. What I'm going to work on now is getting the tubes that go from here, like let's say here to here, right? And then here to there. Then I'll start working on the other piece for the CPU block, and that connects these two also to complete the loop. The radiator is a little bit loose because I'm moving it so I can line it up here. But that pretty much covers the reservoir portion. So I have the tubes in for the radiators, well, at least one of them, and for the GPU. Now I put the red tool here just to show you guys this is not a black and white, although it does look very black and white. So I think for fluid I'm going to add some color. I'm not going to add color on the cables. I'm still going to leave just black and silver or carbon or something like that. I'm going to tilt the machine on its back and we're going to try to measure the front. I haven't figured out how I'm going to measure the front yet. I'll probably use the front glass and we'll see how that goes. So I have the build on its side. I put some masking tape on the inside of the glass. I'm going to use the glass itself as a reference point, all right, for me to draw my lines. Kind of like if I put this glass anywhere in this plane right here, it'd be the same thing, right? So I have a fitting in tube going from the radiator to the glass, and I have a tube going from the CPU block to the glass. Now, I only need to do one set of holes because I know that 2 holes on the CPU block are 28 millimeters apart. I know that this radiator is 25 millimeters from the edge, and this radiator is 25 millimeters from this edge. So I know that these 2 port locations on each radiator are in the same, in this case, y-axis, okay? The x-axis obviously is adjustable. Same goes for the CPU block. The y-axis is adjustable, the x is not, right? So, because the x is the location where the block is compared to the case itself. I do use a digital leveler just to make sure that this is level all the way across so that I end up with something that's actually dead straight or close to it. So what I'll do right now is I will mark where these are, right? And then I will use the glass as a reference to find the distance between these two holes. And then, you know, once I have where all the ports are going to be, I can obviously, like I said, make those adjustments to the X or Y axis when creating what the final piece would look like to combine these two together. So here we have the piece completely made. I have it on temporary extension fittings. For those of you that really only pay attention to, say, like EK fittings, or I guess if you buy into the Corsair stuff, which is just BItspower stuff, you may not know these adjustable fittings. They come in different lengths and they're pretty much very crutch in a lot of build situations. But I have them on here just for now, just so I can get the height correct, right? Because I'm trying to line these two up with this tube. Well, I'm gonna have to cut it down from the CPU block. Once I have it lined up, I will make the final adjustments here. I'll measure how long that tube needs to be and I'll cut it out. So that's pretty much the plan here. You notice I'm super close to the fan. My design, I didn't exactly anticipate being that close to the fan. I did want this part a little shorter, but then if I made this part too short, this part is going to be too long. And I can't exactly move. I guess I could have moved this up a little bit more and then kept this down. But I don't know. I think that strikes a nice balance in terms of length and positioning where it is. But yeah, so I'll get it in there. I'll take a look how it looks. If I have to recut a new piece, I'll do that. So let's give it a shot.
CAD for the case is extremely helpful. What I've done here was to kind of, while I'm waiting for the CPU to show up, I decided I'm going to start working on some of the other visual elements, right? First, I decided to add an additional display screen that's a little bit different than, you know, what you would normally see when people try to put a screen in there. So what I did was I took my inspiration from the Heatkiler CPU block that I'm using, right, which has this shape. And let me just hide the case. You can see where it's going. It's going on the rear of the case, which I'll show you guys obviously once it's also mounted. But anyway, so just a quick description of how this is working here. I'm going to put a round screen in here. So what I've done was I've originally made the cutout that I mentioned for the screen itself. These are inlays that I'm going to make, and you can see here if I can separate. Can I separate this? Why is it not separating? I did not join them. That's strange. Okay, so what I'll do is I'll just remove the rear plate. So this piece right here is going to be one piece of acrylic. Obviously these are chamfered along edges. It's been cut out to, I think, 73 millimeters on this to fit the LCD screen that I'm using, which is a circle one, as I mentioned. I've also pocketed this part for the inlays itself. These are obviously chamfered edges as well to match the Heatkiller block.
So here we are. We have the front distro assembled, the one that is combining the CPU and the radiators. I also have the design piece installed that I showed you guys in CAD. But other than that, all the wires are also installed. These are cablemod cables, and all the front panels connected. So everything's all wired up, ready to go, except for I don't have the CPU. There is a CPU in there at the moment, but that, I think it's a 7900X. It might be a 7950. I'm not sure. But it's one that I put there just to kind of test boot the system dry and also make sure that I have my tubing in the right positions. Today is launch day of the 9950 and 9900X. Some controversy around the CPU about its performance gains. I would say if you're not in a rush to buy, then wait. But obviously I cannot stress enough the importance of reading written reviews from like Tech Power Up and what is that, Anantech, and not just go off what you see on YouTube. Alright guys, so you can see I filled most of the loop. I do have some space left. I'm going to be adding dye now. What you should do when you add dye is you add it, well, 1 or 2 drops at a time. But I know this takes quite a bit, so I'm not too scared of, sorry if I get in the way here, I'm not too scared of overdoing it a little bit. So you can see I'm dropping in the red, and it does get darker as it runs, so you can always drop a little bit and then come back. Don't just kind of go at the bottle and then feel that it's not dark enough and just keep adding, because before you know it, it will get darker than you wanted. So the build's pretty much done. The only issue I did run into was, well, from the build itself, was the fan died on me. The fan that died was the left-right one under the radiator. So that required me to swap the fan out, which I could not have, not under the, sorry, under the motherboard. If I didn't have this low-profile screwdriver that saved my ass, I would have had to drain the loop just to take the fan out. So I will link these screwdrivers. They're a lifesaver, and they're super cheap on Amazon too. So, you know, like I said, this is a new platform. Give it some time. With the newer PPM driver and its GISA updates, there may be better. Well, they're going to have to solve the core latency issue, because that's not small. But also, software needs to be updated to better work with these CPUs. So, unfortunately, how many reviewers do overtime reviews? Not many. So, with that in mind, AMD probably should have done a better job on the launch itself and getting everything ready. For example, I'll give you an example. I don't think most of these boards, their BIOSes with their partners, were updated thoroughly enough. For example, on this X670E Extreme, my temperature throttle limit is 75. Either with the August BIOS or the beta BIOS, setting it to manual and raising it to 95 degrees does absolutely nothing. It still sticks at 75. I also noticed that I'm having harder time. It's taking longer to train the same set of RAM that I've ran on multiple 7-down series without issues. So there's definitely some bugs. There's definitely some twerks that take time. So with that said, thanks for watching. Stay safe and take care.